And we're back. 7.1, video number 2. And so I found a mistake on that last video right at the end there because I was rushing so fast through it. Sorry about that. It's because I had to go somewhere. And so -4 to infinity is wrong because the range is actually at the horizontal asymptote of -2. And so we're going from -2 to infinity. So this should actually be -2 to infinity. Yeah, I fixed it. Woo! Fixed it. Check. Nice. So that was for problem number 16, which will be on Canvas. So I wanted to make sure I fixed that right there for you there. Cool. And then number 17, we actually didn't finish there. So we had a horizontal asymptote. So we had a horizontal asymptote at 1. And so that goes there with this one right there. So if there's a number out in front of the equation, that's the horizontal asymptote. And so it goes along there and then a little bit higher to get to the intercept. So cool. So the domain again is -infinity, +infinity. Awesome. Wow. So -infinity to +infinity. And then the range is going to be from the horizontal asymptote. Use parentheses because you don't actually get there, but close to it. And then up to infinity for the most part. Sometimes it changes for negative growth. So yeah, so this is going to be at the horizontal asymptote, which is 1. And then up to infinity, right? So here's y equals 1, the horizontal asymptote, at y equals 1. And then we're going up from 1 up to infinity. So that's number 17. So number 19 is a shift down 4, right? So we go down 4 there. And so we're going to go 1, 2, so 1, 2, 3, 4. And so, so down 4, so that's not actually where it is on the y-intercept, but that is where the horizontal. So we have a horizontal at -4. And so that's where our horizontal asymptote is, right? There's our horizontal asymptote. And so if we do like an XY table kind of thing, and we plug a -1 and a 0 and a 1, you get e to the -1 minus 4. You get e to the 0 minus 4, and then you get e to the +1 minus 4. And so that's going to help us with graphing. So e to the -1 is actually 1 over e minus 4. And so that's going to be like 1.27 1/3 minus 4. And so that's going to be approximately, what's that's going to be approximately? So that's going to be approximately 1 divided by second e to the first power. So second ln is what I'm pushing there, minus 4. And so -3.63. So -3.63. So we have -1, and then down -3.63 is right about there. And then e to the 0 power, anything to the 0 power is just a 1. And so that's going to be -3. So there's our y-intercept. Our y-intercept is at 0, -3. And then e to the first power minus 4 is like 2.781828 minus 4. 2.781828 minus 4, which is about -1.28. So again, it's second e to the first power minus 4. Yep, so, oh, I was off by a little bit, sorry. So it's -1.28. So about -1 1/3 or so. And so we're going to go over 1 and then down -1 1/3. And there we go. So we're going to go ahead and graph this now. So we go along the horizontal asymptote, and then we take off there. Woo! There we go. There's our graph. Again, domain is negative infinity, positive infinity. And the range is going to be the vertical asymptotes. No, horizontal, sorry. Horizontal asymptotes. And so our horizontal asymptote is going to be -4, again, to infinity. Woo, good job. So try number 17, try number 18, try number 20. Get her done, get her done. You got this. Thanks for graphing these. Okay, so let's see here. We got 21 next. Ooh, so what's 1/3 of the x power? Can you remember? Is it growth, decay, or negative growth? And so I'll kind of remind you of those. So growth goes like this. Negative growth goes down. That's, or neither. It's called negative growth, or neither growth, or neither decay nor growth. The first one was growth. And so I'm guessing because this has a 1/3, so 1/3 is between 0 and 1, so this should be decay. And so decay is where you come along like that. If I could draw a little bit better. Yeah, so that's decay. And so this one should be decay. So what you do is you do an XY table, and we choose a value to the left, in the middle, to the right. And so 1/3 to the -1 power, you have to flip it. Remember, flip it and change it to +1. And so that'll be 3/1 to the +1, which is just 3. So back 1 up 3. Anything to the 0 power is just a 1. And then 1/3 to the 1 power is just going to be 1/3. So over 1 and then up a 1/3. And then there's our graph. So we're going to go along here, go through our y-intercept, along the horizontal asymptote there. Cool. So this time there's a 0 in front, so that's plus. So that's going to be a +0, so that means that our horizontal asymptote is just 0. And this one, of course, is -3. And this one, of course, is +2. Or just 2. Cool. And then our domain and range for all these is negative infinity to the left and to the right. We have those values. And then the range has to do with the asymptotes. So get really close to 0, but don't touch it or cross it. So that's 0 to infinity. And this one's 2 to infinity. Easy peasy, lemon squeezy. So there's number 21. Here's number 23. So that one looks like it has a horizontal asymptote at 2, because that's a +2. And so it is still going to be decay, but you're going to go along the 2 basically. And so I'm going to use, let's see here. So yeah, so do an XY table. And so instead of -1, how do we get that to be 0? Let's try maybe try 1, 2, 3. So probably 3, 4, and 5. The reason why I chose those numbers is I'm looking at the exponent with a -4. So 3 - 4, 4 - 4, and 5 - 4. Right? So now we have 1/3 to the 3 - 4 plus 2. So 3 - 4 is -1. And so that's going to be 1/3 to the -1, which flips and gives us a 3. And so 3 plus 2 is 5. So over 3 up 5. Put a 4 in. 1/3 to the 4 - 4. Again, we're replacing these x values with the x value there, right? We're plugging it in there for the x value. And this was the x value. Cool. And then don't forget the plus 2. And so let's see, 4 minus 4 is 0, so 1/3 of 0 power is just a 1. And 1 plus 2 is 3. So over 4 up 3. And then you put a 5 in, and you get 1/3 to the 5 minus 4 plus 2. And so 5 minus 4 is 1, so that's 1/3 to the 1 power plus 2. And so really, that's just 2 1/3, right? 2 and a bit. So over 5 and then up 2 and a bit. And now you can see that it's going to be woo! And that is going to be decay. So that's going to be decay going along the horizontal asymptote. Nice. Domain and range looking good. And the asymptotes. Okay, beautiful. So Helen is opening her first savings account and depositing $500. So we're going to use our equation there. Let me pause it for a second. All right, we're back. So I just want to give you a kind of a push in the right direction there. So the formula, right? You got to make sure to use the formula for these. And so don't forget the initial population is depositing $500. So we have our initial population for our equation is $500 times, is it positive? Are we increasing or decreasing? So annual interest in the savings account is increasing. So it's going to be your initial 500 plus 6% of 500, which is 0.06. And then it says to compound that twice a year. And so to make it twice a year, we do opposite, which is divide by 2. And then let's see here. So show your setup around your answers, and there's 2 decimal places. So she decides on a bank that offers 6% annual interest, so twice a year. And so time goes in the top. And so let's see. So that's our time, right? So I'm thinking, opening your first interest, so the bank that offers 6%. Determine the amount of money in Helen's account at the end of 3 years. So 3 years, right? 3 years. And let's look at that formula one more time, just to make sure we're doing this right. Give me 1 second. All right, so kind of looking back at our book again. So here's our formula that we're using, if you remember from our lesson. And so P is the initial amount, that's our $500 right there. 1 plus the rate, which is 0.06, divided by the number of compounds twice a year. Oh, and then we also have the number of compounds with time, which I've never really thought of that before. Yeah, so we're basically dividing by n, but then we're doing it to the nth power times time. And so that's interesting. Okay, so then here we go. So that's going to be 3 years, which goes here for time. Let's see here, and then times the 2. And that's twice a year. So I'm going to do that, and I'm going to go and color code that for you. So twice a year goes here and here. And then the 3 years goes here. And then the 6% interest, let's do another color for that. Put as a decimal, so that goes here. And then your initial population is going to be the 500 there. Cool. Because again, the formula is y equals your initial population times 1 plus your rate divided by number of times you compound it with time times the number of times you compound it. Woo! That's a crazy formula, but we got it. So monthly, so all monthly is going to do is monthly is going to change it to 12 months in a year, right? So that just means that your n is going to be 12 is what's going to happen there. But everything else will be very similar, very similar. So you want to go ahead and plug this into your calculator now. So go ahead and plug it into your calculator. So 500 times 1 plus, use parentheses now. So 0.06 divided by twice a year. to the parenthesis, and then that's going to be 3 times 2, which is 6. Cool. So we get $597. Whoa, we got $97 we made. Woo! So that's going to be $597.03 is our answer. So we get, here we go. So then we go ahead and plug that into our calculator, and we get $597. And what was that again? That was like 0.026, which equals $597.03. Yeah, we made $97.03. Wayo. Okay, so that's for this first problem. That's for A. So try it again with B and C and D. Now the continuously part, the hint there is continuous. Let's see. So continuous would be what natural E is. 2.7818281828 is what we're approaching. And so that would be 500 times E to the, is this right? 0.06 times 3? I guess so. I'm not really sure. Continuous. Yeah, let's take a look at our lesson there. So continuous compounding interest has always been calculated an infinite number of times. Okay, so I guess you have to use that formula. So E to the rate times the T. So infinite number of times. And so that's where E comes into play. 2.781828. 2.71828. Cool. Cool. So there we go. Learn something new every day. Wayo. So go ahead and plug that into your calculator to get the continuous compounding. Infinite compounding. It's not much more than doing it daily, actually. And so the higher the frequency, the more money you make. You buy a new mountain bike for $1,100. Woo! Write a model giving the mountain bike's value after 2 years. The value of the bike decreases by 25% each year. Oh no. So that mountain bike is over the years is going to depreciate. It's going to decay in its price. So we're going to do 1 minus. And so it's 25%, so 1 minus 0.25 each year. And so there's our model per year. Use the model to find the value of the bike after 3 years. So 1,100 times 1 minus 0.25, which is actually 0.75. But I really like the 1 minus, that's just nicer. And then 3 years. So we're just going to go ahead and plug that into our calculator. Plug that in our calculator. Again, another way to do it, both ways work, would be 0.75. Maybe that's faster to type into your calculator. Let's try both ways. I heard it both ways. Do, 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 do. I don't know. I think that's just as fine, but whatever. Okay, so we get 464.06. So just to show you, 1 minus 0.25 is 0.75. We get the same answer. So both equal 464.06. So $464.06 rounded to 2 decimal places. Well, my $1,100 mountain bike after 3 years isn't worth that much. It's depreciating all the time. Man, they're so expensive, but they're so useful. Use your graphic calculator to estimate the worth when the value of the bike will be $100. Right? So we're going to go ahead and use our calculator now and go to y equals. We're just going to plug this in. $1,100 times, pause me, try it on your own. Pause me, try it on your own. To the t power, and to the t power is actually x. So we're going to graph it, and you don't really see anything because we're in the hundreds of dollars, so we got to go to our window. And so after 3 years, maybe we'll go all the way, I don't know, 20 years. How long is it going to take? to depreciate that much to 100 bucks. Probably not that long, probably 10 years or maybe 12. And then let's see, so our initial is 1100. Maybe we'll see it now. Nope. So I guess we need to increase really high for the Y value. So maybe we need to increase to 1100. What do you think? Well, it worked, 1100. So we're going to push trace. So again, we went to the window and we changed our Y max to 1100. And that helped us to see, because that's our initial population. And so our initial dollar amount. And so to get to $100 is right about here. Yeah, so right about there. So 8.27 years. It'll drop to 100 bucks. You can go second table as well. And so about 8 years. So about between 8 and 9 years basically, right? So if we want to be more exact, what can we do? Let's see, to be more exact, maybe we round that up to 8.3. Let's see, second calc, value, that's pretty close. So maybe we'll just go with that. Okay, so about 8.3 years will give us that it's worth about $101. So that's pretty close, 8.3. It's tricky. You can do it with the X, but it's tricky with the Y value to predict. So you'd have to do like another value, like, I don't know, 8.31, 8.32. And that's closer, second calc value. Maybe like 8.315. That's close, really close. Maybe 8.319, 8.32 maybe. Second calc, calculate 8.32 years. Yeah, it's really close too. So pretty close. We're getting closer and closer all the time. Okay, cool. So this is all about approximate. That's close enough. Do we get 100 bucks? Okay, beautiful. Okay, so then we're looking at our last one here. So number 27. Okay, so 3 to the x power equals 54. Which of the following must be true? Well, 3 to the first power is 3. 3 squared is 9. 3 to the third power, 3 times 3 times 3 is 27. 3 to the fourth power, I think, is 81, right? 27 times 3 more. Carry the 2, 6, 7, 8. Yep, 81. So yeah, so basically 54 is going to be in between 3 and 4 there. So it's going to be in between 3 and 4. Which is letter C. Woo! Just making sure. Yep, we're good. All right, thanks for watching. Go ahead and do the evens now and check your answers on Canvas. Thanks for watching. Appreciate all your hard work on 7.1. Thanks for watching. Bye for now.